All right, guys, so percent yield and limiting reagent will be for quiz 4, so percent yield notes are here. Percent yield is the ratio of actual or experimental, what we really get out of an equation versus the theoretical yield, so the maximum amount, and that's calculated using stoichiometry. Okay, so the actual, we really have to do an experiment to find that, and the predicted will always be our stoichiometry calculations. That is the absolute maximum. If absolutely every ion or mole reacted, that's what we would get. All right, so ammonia can be prepared by the following reaction. When 7.50 grams of nitrogen reacts with sufficient hydrogen, so that means that nitrogen would be the limiting reagent and hydrogen is in excess, the theoretical yield of ammonia is 9.10 grams. So you can check this by stoichiometry. That's what we would have gotten using our stoich calculations. If 1.72 grams of ammonia is obtained by the experiment, what is the percentage yield of the reaction? So write out your formula. Percent yield equals actual over theoretical times 100%. So our actual is the experimental. We got 1.72 grams in the experiment divided by our expected 9.10 grams times 100%. It's equal to 18.9%, which sucks. As a percent yield, that would be a bad reaction. Okay, we want to get closer to 100, meaning our reaction and our technique is better. 20 grams of bromic acid, HBrO3, is reacted with excess bromic acid, hydrobromic acid, my bad. If 47.3 grams of bromine are produced, what is the percentage yield of Br2? So this is our experimental or our actual. Both mean the same thing. So we need to find our theoretical, and to do that, we need to do our stoichiometric calculations. So starting with what we know, we're talking about bromic acid. So this guy here, we have 20 grams times its molar mass is 128.91 grams per 1 mole. Grams cancel, we're at our mole ratio. So moles is 1 mole under 3 moles of bromine produced. All right, so we get those canceling. We're looking for mass because we do need to compare masses. We could compare moles if that's what we had, but usually it's mass. And the molar mass of Br2 is 159.80 grams. Remember, we do not need to multiply by that 3. Okay, that does not affect molar mass, only our mole ratio. When we finish that calculation, we get that 74.4 grams of Br2 should be produced theoretically. Okay, so using percent yield, it's equal to our actual all over our theoretical times 100%. We should get, oopsie, what was that initial value? 47.3 grams divided by our predicted of 74.4 times 100%. We should get 62.6%. Better than 18 for sure. Still not where we'd want it. We want, for a good reaction and good technique of collecting these solids or liquids, we want in about the 90s. All right, that would be an excellent experiment. All right, so why are they different? So why did we get less than 100%? We can have an unexpected competing reaction. So what that means is we put these two reactants in and we're measuring the mass of one product, but it might be making a side product that diminishes the amount of reactants being used to create our desired product and the one that we isolate and weigh and get the actual value of. How the reaction might be really slow, we might not have waited long enough. The reaction is not stoichiometric, so that means that even if we calculated using our limiting reagent, not all of the limiting reagent is actually used up. So it doesn't go to 100% completion is what we would say. Now these aren't something that you will be able to measure necessarily or predict in Chem 20. The biggest thing we will see is poor experimental technique. So when you guys actually do your own experiments, you may have lost some solid along the way by it being left in a beaker from where the reaction was mixed, or you overfilled the filter paper, or some of the solid was so small it went through the filter paper. One other thing is, even though it says that we consider it insoluble, it does say that it has low solubility on your periodic table. So even though it's insoluble, some of it has just teensy-weensy little bit has dissolved and we've lost that solid. The other thing is impure reactants. So as best I can, I order really good chemicals, but they sit on the shelves for a long time, and sometimes, just as food does, chemicals go bad, and so they are no longer pure, as well as I don't sometimes order absolutely pure reactants. So table salt has other salts in there. It's not pure. Okay, so we can't assume that the total mass that we weighed of that would be the total mass of the reacting compound. If the percent yield is more than 100%, you may find this in one of our gravimetric stoic labs. You did not let it dry. Okay, that is the biggest reason that you can get over 100%, or you did not weigh properly, which is human error, and we don't really want to talk about that. If that were the case, you would have redone the experiment. Okay, so product is usually wet, so you didn't let it dry long enough, and you're actually weighing the mass of some of the water. All right, that's it. You guys can complete quiz number 4 now, and then move on to titrations.